Good day, viewers. You are welcome to Soluble Tutors. As you can see on the board, I'll be discussing about chemistry practical. This will be centered around GCE. As we all know, chemistry practical in GCE, you don't have to go to the lab and practicalize it. It is alternative to practical. And all what you have to do will be done by written. So it means you are expected to know what will come out of the experiment. You are expected to know what will come out of the experiment. So you'll be given a clue. And I'm making this video to explain to you how to pass easily and understand it. I will make it so simple, bring it together so that it can be easy for you. Now, practical chemistry is always of three aspects. So the number one aspect is the volumetric analysis. Number two is the qualitative. So qualitative is also called SWOT analysis. And number three is the general questions. Now, the SWOT analysis is the most difficult one for the students. Students find it very difficult to pass. So this video particularly will be on the cations. I will still make another videos on the anions. Okay, so now going to the cations now. Under qualitative analysis, when you have qualitative analysis, okay, now the cations that we are expected to get based on the WAEC, NECO, GCE of their syllabus, SSCE syllabus, what are we expecting? These are the cations you have to expect: calcium, aluminium, zinc, lead, copper, iron 2, iron 3, and ammonium ion. These are the cations you must know. You must understand how to get them if you really want to pass your SSCE, that is your WAEC GCE chemistry in terms of qualitative analysis. So this is one aspect, the cations. We also have the anions. Now, for you to be able to know how to get this and to analyze it, there are two major precipitating reagents. Let me name them now. Now, the two major precipitating reagents are the first one here is NaOH, that is sodium hydroxide. So the second one is aqueous ammonia, NH3 aqueous ammonia. These two precipitating reagents can be used, or let me say will be used to confirm all this, to test for all this and confirm them at different areas. So let me now give you a sketch of how you can understand it better, on how you can use this to get them. Now, number one thing you have to know is this. The first thing you have to know is that this reagent must first of all be introduced in drops. That's the first stage, in drops. After that, we now go in excess. What are we expected to see? Now, if I have to sketch it out, let me put a sketch to make it so easy. I sketch it here, and I said sodium hydroxide in drops. Now, when you put it in drops, what are you expected to see? The first one, let me put something here like this. Now, when you observe white chalky, like a chalk, white chalky precipitate. I will use PPT for the benefit of this video. But please, when you are writing your exam, write it in full precipitate, please. So white chalky precipitate, what are you expected to see? There are two things that will come up. Now, is either it is Ca2 plus, that is calcium, or it is Pb2 plus, that's lead. Is either it is calcium or lead if we have white chalky precipitate. That's the first thing. Now, let me go to another scenario. If we have white gelatinous precipitate, if you have white gelatinous precipitate, I will use PPT. White gelatinous precipitate, what are we expecting? If you have white gelatinous precipitate, what we are expecting to see are two also. It's either it is zinc 2 plus or aluminum 3 plus. I always remember this because zinc and aluminum are used for what we are using at home for our household materials. Zinc can be used in making roofing sheet and our basin that we wash our hand in the kitchen. So zinc and aluminum can be used to make window blindings. So zinc and aluminum will form white gelatinous, not just white gelatinous precipitate. That's another thing over there. Now, if it happens to be this again, if we have blue gelatinous precipitate, blue gelatinous precipitate, what are we expecting to have there? If it is blue gelatinous precipitate, it should be Cu2 plus. Cu2 plus, that's copper. Copper is always blue. That's blue gelatinous precipitate. Now, let's go for another one. If we have green, sometimes they call it dirty green. Okay, green gelatinous precipitate. Green gelatinous precipitate. What are we expecting? That's iron 2. That's when iron is coming out of the blast furnace. When iron have just been produced. When iron is being produced freshly, it will give us green color. The reason why they always say dirty green is because iron within 2 to 3 minutes of exposure to oxygen or to atmosphere, it continues to turn to iron 3. It comes to iron 3 when it sees oxygen. Now, an iron 3 is brown. Just you can use that to remember, because when your iron is getting rust, it will turn to brown. So iron 3 is brown because it has been oxidized and it's rusting. So now, because there will be a strands of brownish in that green, when you leave it for some time, they now call it dirty green. But when it's coming out freshly, it's always green. So green color. So the last thing I have to mention here is if we have, we can call it reddish brown. We have reddish brown gelatinous, okay, gelatinous precipitate. What are we expected? It is iron 3 plus, iron 3. Looking at this, I've given a skeletal diagram of how you can understand it properly. Okay, I've given a skeletal diagram, okay, of how you can understand this properly. I can clean this place so that you see it very well. You can see this is a skeletal diagram. If you can sketch this by yourself and try to master it, if you didn't understand very well, you can pause this video, you can rewind, take it back, try to pause it and take your time and understand it properly, because this is very, very important. If you can understand this properly, you are going to find it so easy when we are talking about salt analysis and you want to get your cations. Now, this is just in drops. This is in drops. If it's in excess, what are we expecting to happen? Now, I can say this and zinc and probably aluminum. So there are 3 ions that will dissolve in excess. Let me come again. When it's come to excess, there are only 3 ions that will dissolve in excess. And what are those 3 ions? They are nothing less than lead. So those ones that will dissolve in excess. In excess now, it is what? Lead, Pb2 plus, because calcium will not dissolve. And these two gelatinous, zinc 2 plus and Al3 plus. Why do they always dissolve? There's a reason for it. Now, sodium hydroxide is not expected to dissolve any other thing that is a base. Sodium hydroxide is a base. And metallic oxides are basic. Base cannot react with base. That's why they always form precipitate. But why do they react with this one when you put it in excess? When it's in excess, these people turn to be acidic. And that's why any oxide of lead, any oxide of zinc, and any oxide of aluminum, we said they are what? Amphoteric oxides. Amphoteric oxide are oxides that can behave both like an acid and like a base. So at this particular time, when we now put excess sodium hydroxide, this lead, zinc and aluminium, what they do is that they behave like an acid, and naturally their oxide, their natural state is basic, but they behave like an acid in order to now react with sodium hydroxide, and that you find the dissolution, and that's why they're amphoteric. So you can go through it properly and understand it better. So if you have not subscribed to this channel, subscribe and press the notification bell. Like this video so that a lot of people can also see it. The reason why I say you should subscribe and press the notification bell is because when I release subsequent any other videos, you'll be able to be notified and understand it better. If you are an SS3, SS1 student, SS2 or SS3, even university students, you still need practical chemistry. I've made a lot of videos on my channel, so you can check through it and look at the ones that you understand that will be better for you. Thank you. See you in my next video.